Okay, now as we started Unit 1 today, we were talking about exploring exponential models. Much of this unit, again, much of Algebra 2, is a review of Algebra 1, nothing that you haven't seen before. And we know that when we talk about exponential functions, key characteristics, parent function, y equals a times b to the x power, where a is going to be our initial value that we start off with, and b is going to be our growth or decay factor. And when we have exponential growth, we know as we look at the exponential function from the left to right, it is increasing, and then we know then when we have exponential function that is decreasing, we are getting smaller as we go from left to right. And those are based on my decays and my growth factor, so I know that my growth factor is b. So when b is greater than 0 but less than 1, I'm going to have a decay. Okay, that's an exponential decay. And then when b is greater than 1, I'm going to have a growth. These are some basics that we learned in algebra, and not drawn very well here. Okay, I got it. But the asymptote is going to be the point that these lines approach but never touch. So in this case, it would approach or never touch the x-axis, which is y equals 0. Let's see here, exponential growth and decay, and then what gives you a growth or decay factor. And an exponential function, of course, is something with the variable in the exponent. So those are my starts. And we took, for this graphing an exponential function, we went ahead and calculated some points in the graph, and we will go ahead and fill in some tables now. So we will get a XY table for both for A, B, and C. Okay, so as we went ahead as I went ahead and worked the tables off the calculator, I plugged in my function into y equals, and I just went through with the table, and I created table points that were good for me. And I noticed that I'm not shifting left or right for this, so I went ahead and just calculated my x-axis from -2 to 2 is what's important for me, and then of course my y-axis going from 0 up, since I won't have a negative number here. So as I go ahead and as I graph my functions, I know then that graphing this first a function, y equals 4 to the x power. So when x is -2, I have 1/16. When x is -1, I have 1/4, 1, and when x is 1, I have 4, and of course it will keep going at that point in time off my coordinate plane. And if I go ahead, and we have exponential growth there, which is to be expected because my b is greater than 1. And let's look at this next one. I have y equals 1/3 of x. So when x is -2, y is actually 9, which is going to be off my chart. When x is -1, it's going to be 3. And then, of course, we have the same y-intercept of 0, 1, and then 1/3 and 1/9. So again, see a exponential decay as I'm moving from left to right. It is getting smaller, and that would be sensible because my b value is actually between 1 and 0. And then finally on my last function here, because I'm looking to see how they react, I have 0, 2, 1 and 6, which is going to be off my chart, and then -1 and 2/3, and I've estimated my 2/9 and 2/3. So again, my b is greater than 1, so I have an exponential growth, and that's how those sort of look. Let's see, next example, identifying exponential growth and decay. Of course, we've already said that my exponential decay is when the b value is less than 1. So we have 3/4. B equals 3/4. So I know then that that is going to be a decay. And for what is my y-intercept? Well, when my y-intercept is when x is equal to 0, which is going to give me 11 times 1, or y equals 11. So my point is going to be 0, 11 for my exponential decay problem there. And this one, b value is 4. So I have a growth factor, so I have exponential growth. And then when I plug in 0 for y, I'm going to get y equals 3 times 1, because 4 to the 0 power is 1. So y equals 3, and my y-intercept is going to be 0, 3 for those two. Didn't do that to you guys, but let's see. So you should be able to follow those examples, and then we'll go to the next step. And what we know here is I've got down here at the bottom the key concept for exponential growth and decay, and we really looked at this big in Algebra 1, and it is some amount is going to be equal to the initial value invested, or the initial amount, plus 1 times or 1 plus the rate, and it is going to be based on the number of periods, or the number of times that it occurs. So again, in this case where we talk about exponential growth and we're talking about money up here, my rate is going to be, they're asking me, well, suppose that you've invested $500. Well, that's my initial amount. So I know that I've invested $500. I have 1 plus, and it says into a savings account which pays 3.5% interest annually. Okay, well that's 1.0.035 is how you would write 3.5%. And then we don't know an amount of time yet. But it says, when will that account be worth $650? And I believe you can go ahead and place this into your calculator now, and that's what we're doing. We go ahead and created this function, so it's going to be for you to input in the calculator y equals 500.035, and then instead of using t, what you want to use is x in your calculator, and you're going to turn around and figure out that goodness, let me do it real quick. So I went ahead and placed it in there, and looking at my table data, it looks like after 7 years we have $636, but after 8 years we have $658.40. So therefore it took us 8 years. To get $650, and if we were to set this same equation up to find at least $1,650, let's see, we could arrow down our table data, and we could find that it's going to take a considerable amount of time. So yes, it's going to take 35 years to earn $1,666.80. So in order to find that, my time would be 35. So there we go. We're using exponential growth. We're using modeling with exponential functions. And that was some of the materials that we covered today as we were doing our notes beginning our lesson.